Okay, so in this video, first thing we're going to do is review over the types of reactions, and then we're going to work some more balancing chemical equations or some more examples. Alright, so first we're talking about the types of reactions. There's 5 types. We have the first type is synthesis. That's whenever you have 2 reactants reacting and forming one product. Now, reactants are always on the left side of the arrow, and products are always on the right side. And then the arrow means to yield or to produce. So we have 2 or more reactants, and then like one product. Like in our first example here, we got just one product, 2 or more reactants. That would be a synthesis. Decomposition is whenever you have one reactant and 2 or more products. If you only have one reactant, it's always going to be decomposition because that compound is decomposing into its individual elements. A single replacement, and it's also sometimes called displacement. So it means the same thing. That's whenever you have 2 reactants and 2 products. You have an element and a compound on the left side, an element and a compound on the right side. In this example here, we have sodium. That's a single element reacting with magnesium oxide, a compound. So you have an element plus a compound. Producing, we have Na2O with sodium oxide, so a compound, plus Mg, which is an element. So that's single replacement. The sodium is replacing the magnesium and reacting and forming sodium oxide, leaving magnesium by itself. A double replacement is whenever you have 2 reactants, 2 products, you have compounds on each side of the arrow. In this example, we got lithium chloride plus magnesium fluoride produces lithium fluoride and magnesium chloride. In this case, chlorine broke off and reacted with magnesium, and then the lithium reacted with fluorine to produce those products. But if you have all compounds, that is double replacement or double displacement. And then the last type is combustion. For something to be combustion, O2 is always a reactant. CO2, carbon dioxide, and H2O, water, are the products, always. And always you have a hydrocarbon, something that's made up of carbon and hydrogen, like C3H8, could be methane, CH4, could be something like C3H8O2. It's just it's a hydrocarbon and reacts as oxygen. It's always a reactant. Also, CO2 and H2O are always the products. Now, to look at one thing before we balance a few reactions, we look at chemical formula like simply have M magnesium chloride. Now that 2 is a subscript telling us we have 2 chlorines and 1 magnesium. So if I drew these out, if I have say a magnesium in blue and bonded to 2 chlorines, and have a little molecule of that. Well, if I add a number in front, when I'm balancing equations, I'm adding coefficients. That are numbers that can only come in front of these elements or compounds. I cannot change the subscripts at all. And if I put a 2 there, what that coefficient tells me is that I now have 2 molecules of MgCl2. So it would be like saying I have a whole another molecule of this magnesium chloride. If I change this number to 4, that would give me 4 total MgCl2 molecules. So when I'm figuring out the number of atoms, if I count up my blue, I'll have 4 magnesiums total, in this whole thing here. But I'm taking this coefficient and multiplying it by the subscripts. 4 times 1, it gives me 4 magnesiums. And chlorine, 4 times 2, total gives me 8 chlorines. And if I add these up, that's how many I would have in my little drawings. If I have an equation like Ca and then parentheses OH2, what that means is, if I'm counting my number of atoms, I would have 1 calcium. I would have oxygen. I'd have 1 on the inside of parentheses. The number on the outside multiplies by everything on the inside. So that would be 1 times 2, it would be 2 oxygens. And then 2 times 1, 2 hydrogens. Now if I add a number in front of that, if I put a 2, that just doubles all those numbers. And then I have, 2 times 1, 2 calciums. I got 2 oxygens, 1 times 2, and then times 2 more, it gives me 4 oxygens. Same way with hydrogen, I got 1 on the inside, 1 times 2, 2, 2 times 2, this 2 is 4 hydrogens. So the number at the front would multiply by all the rest of them. Now if we do another example like in this compound chemical formula here, I have 3 zincs. I got 1 phosphorus on the inside of the parentheses, but I got to multiply what's on the outside. So it gives me 2 phosphorus. Then oxygen, I got 4 on the inside, but I got to multiply by this 2, it gives me 8 oxygens. Now if I add a number in front of this, like a 3, and I have 3 molecules of that, 3 separate molecules of zinc phosphate, I got to multiply that by each subscript. So that would give me 9, 3 times 3, it would give me 9 zinc. Phosphorus, I got 1 on the inside, times this 2 is 2, then times the 3 here gives me 6. And then oxygen, I got 4 times this 2 is 8, 8 times 3 gives me 24 total oxygens. So we have to understand that before we balance equations. Now let's look at some more examples. If I'm going to balance equations, I use, what I call a T-chart. I want to separate my reactants from my products. According to the law of conservation of mass, or law of conservation of matter, atoms are not created or destroyed during chemical reaction. They are conserved, meaning I got to have the same number of atoms on the product side as on the reactant side. All atoms are doing in chemical reaction, they are just rearranging to form new compounds, new substances. So if I draw my line down through here, and then I write down what each element that makes up this reaction. I have, gallium fluoride plus cesium produces cesium fluoride plus gallium. Before I even start, I can identify what type of reaction this is. I've got 2 reactions, 2 products, so I know it's got to be, either single replacement, double replacement, or combustion. And I look, and I got a compound plus an element on the left, and I got a compound plus an element on the right. So that can only be single replacement. Because I have element plus compound produces element plus compound. Now, to balance this, according to the law of conservation of matter, I need to get the same number of atoms on each side. But I got to count how many is here now. I got gallium that makes this up, fluorine, and cesium. That's the 3 elements in this reaction. So I count on the left, I have 1 gallium. Fluorines, I have 3. Cesiums, I have 1. And by the way, in your notebooks, you need to start writing this example down right here, the ones that we work. It's been a review up to this point right here. Now on the right, I have 1 gallium, I have 1 fluorine, and 1 cesium. So I can only balance my fluorines. So I cannot do this. I cannot go and add a 3 here, because if I do, I change the chemical formula and I change that into something else besides cesium fluoride. I can only add a coefficient in front here. I can't add it in the middle, only up front. So I need 3 fluorines. I'd have to put a 3 here, because then 3 times 1 gives me 3 fluorines. But it also changes my cesiums. It's changed my cesiums to 3 also. So I look, it's not balanced. My cesiums are not balanced. So let's go back over to the left. I can only add a number here. I need 3 total, so I'd have to add a 3 here, because 3 times 1 gives me 3. And then I check. Gallium's 1, 1. Fluorine's 3, 3. Cesium's 3, 3. So that's balanced. But, the coefficients, if it's understood that there's not 1 in front of there, that you don't have to put 1. But there was really nothing wrong with saying that right there, because that's what it means. I'm writing those in if you'd like, but you don't have to. Understood. Alright, next example is, it's a little bit harder example. So we're getting into some with polyatomic ions. So I'm going to first identify what type of reaction this is. If I notice I got two reactants, 2 products, they are all compounds. I got compound plus compound produces compound plus compound. That can only be a double replacement. Now I'm going to write down the elements to make this up. I have lead, I got Pb, I have oxygen, I have hydrogen, and chlorine. And it's going to be like that on each side. And then I want to count how many I have on each side. On lead on the left, I have 1. Oxygen, I have this 1 times 2 on the outside, gives me 2 total. Hydrogen, I got 1 inside parentheses times 2. Then I got 1 more right here, so that's going to be a total of 3. They're separated. And chlorines, I just have 1 on the left. On the right, Pb, I have 1. Oxygens, I have just 1. Hydrogens, I have 2. Chlorines, I have 2. So I got to decide what I'm going to start with the balance. I can start, it could be easiest to start with my either my oxygens or chlorines. I'm going to start with oxygens. I have 2 on the left. I need 2 on the right, so I'm going to have to go and put a 2 right here. That's going to make me have 2 oxygens. It's going to change my hydrogens to 4. 2 times 2. So now I can go and I can balance my chlorines. I got 2 on the right, I need 2 on the left. I can only put 2 right here. That's going to change my chlorines to 2. It's going to change my hydrogens. I got this 1 times 2 here, 2 right there, then add plus, 2 more, gives me a total of 4. Then I check. I got 1 and 1 lead, 2 oxygens, 4 hydrogens, 2 chlorines. So that is a balanced reaction. The way it happens is 1 molecule of PbOH2 reacts with 2 molecules of HCl to produce 2 molecules of H2O plus 1 molecule of PbCl2. That's the ratio of molecules, how this reaction happens at the simplest level. Now if we look at one more example, I'm going to give you a chance to stop this video if you need to write these down. If I'm going too fast. Now this reaction says rubidium nitrate reacts with beryllium fluoride, BeF2, to produce beryllium nitrate plus rubidium fluoride. Now, if we look at what type of reaction this is, well, we have two reactants, two products, and they're all compounds. I got a compound plus a compound produces a compound plus a compound. This can only be a double replacement reaction. And if I notice something, I have, we just learned about polyatomic ions a few weeks ago, and I know that the first element there, this RbNO3, has three elements in it. It's got rubidium, nitrogen, oxygen. And I know that NO3 is a polyatomic ion. We learned about those. And I can shorten this up from balancing it if I recognize a polyatomic ion, and if it looks the same on each side, I can leave that as an ion instead of writing it as a two individual elements. Instead of breaking it up into nitrogen and oxygen, I can leave it as NO3, because NO3 is a polyatomic ion. On the right side, I got two of them. On the left, it's NO3. I just got one of those. I think it's more simple. You can leave it, break it up into nitrogens and oxygens separately and balance it, just fine. But for me, I think it's easier to leave it. And if I recognize it's a polyatomic ion and it looks the same on each side, like it's NO3 on this side, it's NO3 on that side, on the right side, then I can just leave it as an ion. If it was like NO3 on the left side and it was NO2 on the right side, then I couldn't do that. I'd have to split it up into the individual nitrogen and oxygen atoms. But what I mean by this is, this is made up of rubidium, and then I have this NO3 ion that's the same on each side. So one, I could just leave it like that. But, I don't have to do it like this. It's just a shortcut way. This is also made up of beryllium and fluorine. Now on the left, I have one rubidium. NO3, I have just one of those ions. Beryllium, I have one. Fluorine, I have two. On the right, I have rubidium, I have one. NO3, I have two of those ions. Beryllium, I have one. Fluorine, I have one. Now, a lot of times these equations that look like they would be the hardest ones are the easiest ones to balance. A lot of times you can just add in one or two coefficients and it balances them out. So if I want to balance, I can start with, say, my fluorines. And if I go my fluorine, I can put it on the right. I need two. I have to put a 2 right here. So that changes my fluorines to 2. It changes my rubidiums also to 2. Then I go on the left side and let's say I balance my rubidiums. I have to put a 2 in front here. That gives me 2 rubidiums, but it also changes my NO3s. If I have 1, that's right here, this NO3s, 2 times 1 gives me 2 total, and that balances it out. I got 2 rubidiums, 2 NO3s, 1 and 1 berylliums, 2 fluorines. So that should be balanced. So the way this reaction happens, the simplest level, the way the ratios of the molecules are, 2 molecules of RbNO3 react with 1 molecule of BF2 to produce 1 molecule of BeNO32 plus 2 molecules of RBF. Now, your assignments today will be to look at a second for this stuff. Something's wrong. Alright, so in your assignment today, you are to do this activity, balancing equations online, and show you, so what are three things is a balanced equation do for you? You're going to cite one first here, these chemical equations, to fill in these notes. And then you're going to cite two, and I have these down in the, below the assignment there, so you don't have, you can just click on that to go to the link. And read these directions carefully. You're going to click the button for directions, read carefully, and then you're going to click Start Game to give it a try. Start by adding a 1 in each box. So that's on part 2. So to show you that, it'll bring you up to this right here. There's 11 questions, 1 of 11, and it's got in your boxes there. You're supposed to write these reactions once you balance them. So you start by adding a 1 of each thing before you balance. And then you look and check, does that balance it? Just having 1 of each, because if something doesn't need any coefficients, it's already balanced. And that would balance this reaction. So once I get to this point, I would, and once I think I have it balanced, I would write down the 1 Fe plus 1 S produces 1 FeS. And, when you balance it, it tells you this balance correct, and then it answers a question here. So in those boxes where you write these reactions down, there's questions, and those, like the first one in Latin, ferrum means iron. From ferrum comes the symbol Fe, and sulfur is a yellow powder. So answer those questions as part of the online activity, and you'll turn that in whenever you're completely finished. But there's 11 of these. Once you're done, it'll bring up the second one, and you balance it.